Today's lesson is on section 4.3, graphing using intercepts. So far in this chapter, sections 1 and 2, we've been graphing just using this first method, which is finding solutions or finding ordered pairs for an equation. What does that look like? Well, I've told you, we've been working in class here on trying to get an equation in slope-intercept form first, and then using this method. What does slope-intercept form look like? I often describe it as having y by itself on one side of the equation, or solving it for y. So the equation might look like y equals 2x plus 3. As long as y is on it by itself here on this left side of the equation, this is what I want. And then it's a good time to use that method. Then what do? Well, I make a little xy table and plug in some numbers. It can be any numbers, but I usually pick out 0, 1, and 2 because those are usually easy numbers to plug in. And I find my y coordinates, and those are my ordered pairs that I can use to graph that equation. Well, today now we're going to take a look into this second method using the intercepts of an equation and finding those so that I can make the graph of it. The x and y intercepts, we'll talk about what those are in class, but intercepts, what you can think of those like. Intercept is like when two things cross. So if I'm finding where two things cross, we're talking about the graph of our equation. And in this case, we're talking about the x and y axis of the graph. So it's where the line hits the x-axis and where the line hits the y-axis. That's the x and y intercept, respectively, for this equation. And I'll show us what that looks like here in just a little bit. First thing I want us to write down, though, about using this method is it works best when we have an equation in this form right here, standard form. And we've talked about this earlier in this chapter. But standard form, what does this look like? Well, our variables x and y are actually on one side of the equation, or on the same side of the equation, and then we have some constant on the other. So again, here's the general form, ax plus by equals c. For example, though, what this an equation might look like, we might have something like 3x plus 4y equals 12. There's an equation in standard form. If I have an equation in this form, then method number 2, using the x and y intercept, this method's a little easier to graph with, or a little quicker to get to the graph of my equation if I can use this method effectively. So that's what we're going to talk about today. How can I use this particular form of the equation to graph? When using this method, I also want students to understand one more thing in terms of why does this work, or how can I just find these two intercepts and make the graph of an equation. I will ask them in class here is how many points does it take to find, how many points does it take to make a line on a grid? And then we have talked about it before in class, but hopefully we'll remember it only takes 2 points to make a line. When we're using ordered pairs method, that first one at the top, I usually have us find 3 ordered pairs because it's kind of a double check to make sure that we're getting the correct graph. If I find 3 points that fall in a line and go right in a row and it should make a linear straight line, then I've probably done some of the problem right, or at least most of the problem right. It's a good chance. But if I don't find 3 points that fall in line, that tells me it's kind of a double check to see if I've done everything correct. But really, how many points do we need to make a line? We only need 2 points. As long as I have 1 point somewhere in the grid, and then some other point, well, then I can draw a line through both of those 2 points. What we do in this method is we find the 2 easiest points we know how to find when the equation's in this form. We find the x-intercept and the y-intercept. Again, the x-intercept is just along the x-axis. The y-intercept is along the y-axis. Remember, intercept is where two things cross. And so what we're saying is, well, where is this line? Let's say I graph some equation. Most equations will have a line that goes through the x and y axis. When I graph an equation, where the x and y intercept? The x-intercept in this problem, or for this equation, would be right there, this point, right where the line, or the graph of my equation and the x-axis cross. So this I would call the x-intercept. And there's an easy way to find that if I have the equation in standard form. The y-intercept then is right here at this point. This is my y-intercept. And I'm going to show us how we can find those 2 points very easily when I have an equation in this form, in standard form, and then I can use this second method, graphing using the intercepts. If you're taking notes along with this lesson, at the top there I have something to write down, intercepts, as I've been talking about on the first page. Those are where the graph of a line crosses an axis. And again, the x-intercept, going back to that previous page for just 1 second, just making sure we understand that. Here's the x-intercept, this point, because it is where the line crosses the x-axis. Here's the y-intercept, this point, because it's where the, it's going the wrong way there. It's where the line crosses the y-axis. So again, the x-intercept where it crosses the x-axis, the y-intercept where it crosses the y-axis. We're going to find those 2 points. Those are the intercepts of a graph. And if I find those 2 points and plot those, I can make the graph of an equation. And as I'll show you here, they're pretty easy to find when I have an equation in standard form, like I've been telling you. One more thing I want us to understand, a little bit more background on why this works so easy and how we can find the intercepts just by plugging certain numbers in. I'm going to talk about these 2 questions here. How can we find the intercepts? One thing I want us to realize is there's something in common with all the points along each of the axes. So for example, this question up here, what do all the points have in common that are on the x-axis? If I look at the x-axis, it's made up of all these points. Kind of, if you can see it, I'm making little points along the line, but all these points are on the x-axis, and there's something particular, something special about all the points that lie along the x-axis. So like the point right here, we'll say the coordinates of it are 3, 0. As we did plotting points before, we should know that. So I just go to the right 3 and up or down 0. There's the point 3, 0. If I went way over here, this point would be 9, 0. If I went back, this point would be negative 3, 0. This point right here would be negative 8, 0. And you would notice kind of a pattern about all the points that are along the x-axis. And we'll talk about this in class, but what you notice is look at all the y coordinates. Look at all the second points, the second numbers in each of these ordered pairs. They're all 0. Because notice along the x-axis, I haven't moved up or down for any of those points to plot them. So going back to the top here, is I'll have you copy down your notes. All the points along the x-axis have a y coordinate that is 0. All of them look something like this. It's some number and then 0. Because again, we've moved so much left or right. That's what the first number stands for. But the second number says we haven't moved at all up or down. So that's why we're still on the x-axis. So something to note is that whenever we're on the x-axis, all the points have a y coordinate that's 0. Again, I'll show you why that's important in just a second, but that's something first to kind of note. Same with the y-axis. Let's take a look at that. What do all the points along the y-axis have in common? If I plot some of those points, this point would be 0, 3. This point right here would be 0, 5. Up here I'd have 0, 10. Down here I'd have 0, negative 3. 0, negative 7. Oops. I'd have all these points, and again, what do you notice about these? There's some kind of pattern for these points as well. Well, you can see that all the first numbers, which are the x-coordinates in each of these ordered pairs, all of them are 0. So again, I'll erase this first up here, but so you can kind of see it. What do all the points along the y-axis have in common? All the x-coordinates are 0, because they're saying that we haven't moved left or right at all, but we have gone up or down on the y-axis. So all of these points look like 0 for x, and then well, whatever that second number ends up being. So just something to know, and again, something that will be important here as we start graphing these, is something to know here. Here's why this works, or a reason why this works, is that the points along the x and y axis are kind of special. For the x-axis, all the y coordinates are 0. For the y-axis, all the x coordinates are 0. So now I'm going to show us, using that information up top, how to graph one of these equations and why it's important. This problem says graph the following equation. It's in standard form. It says 2x plus 3y equals 6. So in the past, or the previous 2 sections, what we would have done for this problem is changed it so it's y equals. We would have solved the equation for y, got it in slope-intercept form, and then plugged in 0, 1, and 2 and gone from there. But instead, here's what we're going to do. We're going to use intercepts method instead. Because it's in standard form, this will be an easier method. You can still make an XY table, as I'll tell the students. And I think it actually still helps to do so, to kind of think of what points you're finding. But here's what we're going to do instead. Notice, like I talked about at the top, that, or the top red line there, it says all the points on the x-axis have a y coordinate that's 0. So in these problems, if I'm going to try to find one of the intercepts, or in particular, if I want to find the x-intercept, well, what do I know about all the points along the x-axis? They all look something like this, where it's some number and then 0 for my ordered pair. So the y coordinate is 0. So here's what I'm going to do. Coming down to my table, instead of plugging in, for ordered pairs method where I plug in 0, 1, and 2 for x, instead here's what I'm going to do. Since I know all points along the x-axis have a y-coordinate 0, I'm going to put in 0 for y in my equation, and then see what I get for my x when I solve the equation for x then. Here's what happens when I put in y, here's why this works. When I put in 0 for y, look at what's going to happen. Well, it's kind of like I say 3 times 0 then at this point, and anything times 0 is just going to be 0. So this 3y, as you'll see me do on the board, or as you'll see me do in lessons, I usually just kind of cross it off then when I'm putting 0 in for it, because essentially it just goes away. 0 times anything gives you 0, so that's just going to go in my problem. What's left? Well, on this side I have 2x, and then I have equals 6, and if I solve this little equation I get x equals 3. So what do I know? Well, I know when y is 0, x is 3. This is like an ordered pair, and what do you know? If I go over 3 and up and down 0, it's on the x-axis, so this must be my x-intercept for this problem. Now if I go back to the original problem, go back to the original equation here again, and I'll do this part in green, I'm going to try to find the y-intercept. Well, what do I know about all points along the y-axis? I kind of got it covered up here by my recording, but what I know about all points along the y-axis is they have an x-coordinate of 0. So down in my table here now, down here, what I'm going to do is I'm going to put in 0 for x, and then see what I end up getting for y when I solve the rest of the equation. So I'm going to put 0 in up here. And again, what's going to happen? Well, 2 times 0 is just going to be 0. So essentially, again, you'll see me cross that off all the time, but I'm just going to cross off 2x for this part of the problem, because now what's going to happen is that's going to cancel out. And bringing this down here, I just have 3y equals 6 left. If I divide both sides by 3, I get y equals 2. So when I put in 0 for x, I got 2 for y. Again, what do you know? The point 0, 2, that's on the y-axis. That's my y-intercept. So here's what I've done is I found the two intercepts just by putting in 0 for each of the two numbers, each of the two variables, x and y. I've got 2 points. As long as I have 2 points, I can make the graph of an equation. So I graph a line that goes to those two points. There's the graph of that equation, and I did it using method number 2 here, finding the two intercepts, x and y intercept. One more thing to write down in case you're a person who likes to write things down in terms of what we did there in that problem. If I want to find the x-intercept in a problem, so what I do is I find the x-intercept is the x-coordinate of a point where the graph crosses the x-axis. So to find it is kind of the important part of what to do here. To find the x-intercept, let y equal 0, and that's what I did. I plugged in 0 for y, that canceled out the y term, and then I just solved the rest of it for x and found out what the x-intercept was. To find the y-intercept, I just kind of do the reverse. The y-intercept is going to be the y-coordinate of a point where the graph crosses the y-axis. And to find that, I'm just going to let x equal 0. Because again, in a point, that means I haven't moved left or right at all. I'm still on the y-axis, like that green point I did up top on this example problem. So again, if you like to write things down or to have that in your notes, that's probably a good thing to note. Here's how I find the x-intercept. Here's how I find the y-intercept. So then just going through a few problems to make sure we get the idea. Again, if I'm going to use method number 2 here, it's because I see that the equation's in standard form. I have x and y on the same side and then some constant on the other side. So this equation's in standard form. This means it's a good time to use the new method now, graphing using intercepts. So what I'm going to do is I can still make my xy table, but instead of putting 0, 1, and 2 in, it's not as easy in a problem like this to do that. Instead, what I'm going to do is I'm going to put 0 in for x. I'm going to put 0 in for y as well, because that'll find my two intercepts. When I put 0 in for x, it'll find my y-intercept. When I put 0 in for y, it'll find my x-intercept, just like I talked about on the previous page. So here's what I'm going to do. I'm going to put 0 in for x. I'm going to plug that in and see what happens. Well, when I put 0 in, again, here's why it works out. 8 times 0 is just going to give me 0. So again, you'll see me do that often on the board, but I'm just going to cross out 8x because 8 times 0 gives me 0. That's just gone. All that's left is the 6y equals 24. So I'm going to rewrite that as a little one-step equation. Divide both sides by 6. I get y equals 4. There's my y-intercept. 1, 2, 3, 4. The point is left to right 0 up 4. It's on the y-axis. That's the y-intercept. Coming back to the original problem now. In my table, it says I still have to plug in 0 for y. So I'm going to put 0 in right here and see what I get when I solve the rest of the equation for x to find the x-intercept. What's going to happen is I'm just going to cross that off because 6 times 0 is just going to give me 0, so that's going to go away. All I'm going to be left with is 8x equals 24. Divide both sides by 8, so x is going to be 3. There's my x-intercept, 3, 0. Once I have 2 points, I can graph a line. I just got to draw a line through both those points. There's the graph of that equation using this second method, intercepts method. I'll do one more example here for us, especially because this one does have just one small thing to catch in here, but it's something we've talked about all year, so I think people will be able to catch it. So again, this equation, it's in standard form. It's got x and y on one side, constant on the other. So I'm going to use this new method, graphing using the two intercepts. To do that, I'm going to plug in 0 for x. I'm going to plug in 0 for y, each one separately. See what I get. Those will be my x and y intercepts. When I plug in 0 for x in this problem, 3 times 0 gives me 0, so that's going to go away. Just one small thing to catch. And remember is that when I see the subtraction sign in front of the 4y, that means I have to think of that 4y like negative 4y. Again, you could chop dash a 2 to remind yourself about that. But I just like to think when I see a subtraction sign in front of a term, just think of it like it's negative. I have to keep that negative sign with it when I go to the next line here. So the 3x is gone, but that subtraction sign turns into like a negative. So it's like negative 4y. That's got to stay with that term. When I divide both sides by negative 4 in this little one-step equation, I'm going to get y equals negative 3. I haven't seen a negative number yet, but obviously that can definitely happen. 0, negative 3 is still a legitimate point. I just go left to right 0 and down 3. There's my y-intercept. Going back to the original equation, I'm going to find the x-intercept. So what's going to happen is I'm going to put in 0 for y. 4 times 0 is going to give me 0. So again, I just kind of cross it off and up here on the board just to kind of show that it's going to go away. All I'm going to have left here is 3x equals 12. Divide both sides by 3. I get 4 for y, or sorry, x equals 4. So that's my x-intercept, 4, 0. Plot that point, 1, 2, 3, 4, up or down 0, so there's that point. Graph the line. There's the graph of my equation using intercepts method. Again, a brand new method, but one I think once we get comfortable with, we'll find that it is useful, especially when the equation is in standard form.